In this tutorial, we'll be creating a top-down shooter in 6 simple steps using Unity and C#. Let's get started.
Alright, so I'm here inside of Unity. I've got a brand new project opened up. The first thing that we need to do is to import all the assets that we're going to be using throughout this tutorial. Now we went ahead and created a cool little Unity package, so you just need to go ahead and download that Unity package using the link in the description. It's completely free, guys, and we'll send it over to you. And once you have it installed on your machine, just go ahead and drag and drop it inside of your project panel. Let's go to import that Unity package. All right, so we're just going to go ahead and import everything that's inside of it. Reload the scene, and there we go. We're inside of our cool little game world. So we've got a player character, cool little background, some obstacles, some post-processing. Things are looking already very nice. All right, so let's start off, guys, with step number 1 to create a top-down shooter game in Unity, and that is to create the player controller. So we want to be able to move the player character around using the arrow keys on our keyboards.
By the way, guys, this video is sponsored by our course, Game Dev Rockets. It's the ultimate roadmap to become a pro who actually makes money from his creations. There we'll create dozens of different video games, starting with small projects and ending up making an epic FPS which you'll publish and sell on Steam. You'll learn all about game art, programming, using the Unity game engine, marketing, and more. You can sign up now using the link in the description.
So to do that, I'm going to start off by creating a brand new folder for my scripts. Then I'm going to go inside of that folder, right click, and create a brand new C# script that I'm going to call player controller. Once that script has been created, I'm going to select my player in the hierarchy, and I'm just going to drag and drop the player controller script inside of the inspector. Like that, we've got now the player controller script attached to our player character game object. With that done, I'm just going to double click on that player controller script to open it up inside of our text editor. In my case, that's Visual Studio. All right, so here we are. The first thing that I'm going to do is to create a public float variable for the speed of my player character, and a line of code with a nice little semicolon. So we're creating a public float speed variable to be able to control the speed of our player. All right, so once we have that, I'm going to go inside of the update function. We need to go ahead and capture the input from the player. So we need to know what arrow keys is the player pressing down. Is he pressing down the left arrow key, the top arrow key, both at the same time? We need to have that info. To do that, I'm going to create a vector3 variable called player input, let's say, and it's going to be equal to a new vector3. Let's put a pair of parentheses and end the line of code with a semicolon. Now, inside of these parentheses, we need to specify what are those 3 numbers to make up the vector3. So we need to specify what's the x, y, and z numbers. For the x, we're going to say input.get access raw, then put a pair of parentheses, pair of quotation marks, and I'm going to type horizontal. There we go. So for the x number, we're using input.getAccessRaw horizontal. For the y number, so the up and down direction, I'm going to use input.getAccessRaw, then put a pair of parentheses, a pair of quotation marks, and this time I'll type vertical. And for the z direction, of course we're in a 2D game, so there is no z direction needed. I'm just going to put 0. Okay, fantastic. So input.getAccessRaw horizontal is going to capture the input for the left and right arrow keys. It's going to be equal to 0 when neither the left or right arrow keys are being pressed down. It's going to be equal to -1 when the left arrow key is being pressed down. And it's going to be equal to 1 when the right arrow key is being pressed down. The same thing for input.getAccessRaw vertical. 0 if neither the up and down arrow keys are being pressed. 1 if the up arrow key is being pressed, and -1 if the bottom arrow key is being pressed. We could go ahead and test this out by creating a print command and printing out our player inputs. Let's not forget the semicolon. Let's save the script and go back to Unity. All right, so if we go ahead and open up the Unity console right here and press on the play button, we'll see that at the moment, the vector3000 is getting printed out because I'm not touching any of the arrow keys. Let's touch the left arrow key, and you'll see that we've got -1 getting printed out for the X direction. Let's click on the right arrow key, and you'll see that 1 is getting printed out. If we click on the up arrow key, 1 for the Y number is getting printed out. And so there we go, guys. We're now successfully capturing the input from the player, but of course our player character is still not moving. So let's click on the play button to exit the play mode, and let's go back to my C# scripts. I can remove this print line of code. Now we have to actually go ahead and move the player character. To do that, I'm going to modify his transform.position. So we're modifying his current position, and we're actually going to increment it. So we're going to add something to his current position. What do we want to add? We want to add our player input dot normalized. So why do we have to add this dot normalized on our player inputs? Basically, dot normalized is just going to make sure that the player character will not move faster when moving diagonally. So we also have to add that just to make things nice and fair. All right, so player input dot normalized, then we're going to multiply, so using the star sign, we're going to multiply with our speed variable so that we can control how fast the player character is going to be able to move with this speed variable here. And the last thing we have to do is multiply with time dot delta time. So what is this time dot delta time? Basically, whenever we're working with speeds, we're going to have to multiply with time dot delta time to make the movement frame rate independent. That just means that the player character will move as fast on a slow PC or on a very fast new generation PC. So always add that times time dot delta time. All right, fantastic, we're all done, guys. Let me give you a quick recap. We're creating a public float variable called speed to control the speed of our player controller. Then we're capturing the inputs using the arrow keys on our keyboard with this line of code here, and then we're finally actually applying the movement with this line of code right here. All right, fantastic, we're done. So let's save the script by pressing Ctrl+S or Command+S if you're on the Mac, and let's go back to the Unity game engine. Okay, so let's set my speed to, let's say, 8, for example. There we go. And now let's press on the play button and test this out. And just like that, guys, with 3 lines of code, we've already got a player character that can move using the arrow key input from the player. Fantastic. All right, guys, now let's move on to step number 2 to make this top-down shooter game here inside of Unity. And that is that we want our wand, so the player's weapon, to rotate and face the mouse cursor. So if we go inside of the player game object, you'll see that there is this player weapon game object. Now, if we take the rotate tool by clicking E on the keyboard, you'll see that it is rotating really nicely. Now, we basically want to create a script and make sure this wand is going to automatically rotate like this and face wherever our mouse cursor is inside of our game. So let's do that right now, guys. So I'm going to go back to Visual Studio. I'm going to go back to my player controller C# script. And the first thing that we want to do is to take a reference to that weapon, to our wand. So I'm going to create a public transform variable, and I'm going to call it weapon. There we go. So if we save the script and go back to Unity, we're now going to be able to select our player character here and simply open up the player and drag and drop the player weapon object inside of this weapon slot. Okay, fantastic. Now let's go back to our update function after this movement code right here, and let's work on the weapon rotation code. I'm just going to create a little comment, weapon rotation, and we can create a comment right here for the player movements. Okay, so weapon rotation. The first thing that we need to do is to create a vector3 variable called displacement. There you go. And this variable is simply going to be equal to our weapon's position, so weapon.position minus the position of our mouse cursor. So that's input.mouse position. There we go. Now, there is one problem. Weapon.position is in Unity world space, so using Unity's unit system, whereas input.mouse position is in screen space, using pixel coordinates. What we have to do is convert input.mouse position from a screen space into a world space. The way we do that is by wrapping it inside of camera.main.screen to world points. There we go. I'm going to add a pair of parentheses before it and after it. Okay, so now that we have that displacement between our current weapon position and the current input.mouse position, now that we have that, I'm going to come down here and create a float variable called angle. And this angle variable is going to be equal to mathf.atan2. So we're using the tangent function. Inside of thisatan2 function, I'm simply going to say displacement.y, displacement.x. So basically what this line is doing is that it is calculating the angle between our weapon and our mouse cursor. Now this angle is getting returned in radians and we want it in degrees. So I'm just going to simply multiply this with mathf.rad2deg. That's going to convert the radians into degrees. Okay, fantastic. So now guys that we have the angle, now that we've calculated the angle between our weapon's position and our mouse position, we want to go ahead and rotate the weapon to face the mouse cursor. So to do that guys, I'm going to say weapon.rotation, and we're going to set it equal to quaternion.Euler. Let's put a pair of parentheses and a semicolon, and now we need to specify the X, Y, and Z rotation of our weapon. So for the X and Y, we don't care. So let's put 0F and 0F. We don't need to take care of that. All we want to change is the Z rotation on the weapon. And what we're going to put is, of course, our angle that we just went ahead and calculated. So we're setting the weapon's rotation to be equal to our angle. So let's save our script by pressing Ctrl S or Command S if you're on a Mac, and let's go back to the Unity game engine. Alright guys, you'll see that the weapon is rotating towards the mouse cursor, but it isn't exactly well aligned. You'll see that here, the mouse cursor is on the left and the weapon is facing up. So we need to add some sort of offset. So I'm going to go back to my C# script here, and I'm going to create a public float variable called offset. There you go, and then here I'm going to say angle plus, I'm going to add my offset variable. So let's save the script again, Ctrl S or Command S, and go back to Unity. Alright, so in my case, I need an offset of 90 degrees. So I'm going to write 90 here for the offset variable, and now press play. And there we go, fantastic. I'm just going to make this window bigger so you can see it better. And you'll see that our wand, our weapon here, is correctly rotating to face the mouse cursor. So there you go guys, we've got step 1 and 2 are complete. We've got movement and weapon rotation done. Alright, let's move on to step number 3 to create our top-down shooter game here inside of Unity, and that is to get shooting working. Alright, so the first thing that we want to go ahead and do is to create a shot point. So we have to specify, we have to let Unity know where do we want the projectiles, the fireballs, to get shot from. I'm going to right click here inside my hierarchy and create a brand new empty game object that I'm going to call shot point. Okay, I'm going to reset the transform components just to keep things nice and clean. And now we have to go ahead and parent this shot point to our weapon. So I'm going to open up my player game object here. I'm simply going to drag and drop my shot points inside of the player weapon object. Great. Now I could press F to frame on it. And now guys, of course, we have to go ahead and place the shot point correctly at the tip of our weapon. So I'm going to take the move tool and I'm just going to place it somewhere around here. All right, fantastic. Now guys, I'm going to go back inside of my C# script. So we need to go ahead and create a couple of variables. The first one we need is a public transform variable for my shot point. So that's the object that we just went ahead and created. Then I'm going to create a public game object variable called my projectile. So this is the actual game object that we want to go ahead and spawn. Then we're also going to need to make a timer system because we don't want the player to be able to shoot all the time. Once he shoots, he's going to have to wait for a couple of seconds or milliseconds before he can shoot again. So I'm going to create a public float variable called time between shots. There we go. And we're also going to make a private variable float called next shot time. Okay, fantastic. Now let's go inside of our update function. Once again, I'm going to make a little comment, shooting. Alright, so the first thing that we want to do, guys, is to make sure that the player is pressing down on the left mouse button. We only want to go ahead and shoot if he's pressing down on the left mouse button. So I'm going to make an if statement checking if input dot get mouse button down. Then I'll put a pair of parentheses and put in the number 0. So get mouse button down 0 is for the left mouse button and get mouse button down 1 is for the right mouse button. Okay, so now that we know that the player is pressing down on the left mouse button, we need to make sure that he is allowed to shoot. So remember guys, I told you that we're going to create that timer system to make sure that the player character could only shoot, let's say, every 200 milliseconds. So to do that, I'm going to create an if statement checking if time.time, so if the current time in the game is greater than our next shot time variable. If that's the case, then I'm going to set next shot time to be equal to the current time in the game again, so time.time, and we're going to add to it our time between shots variable. So that's how we create our timer system. Now in here, we actually want to go ahead and shoot, actually go ahead and spawn in our projectile. To do that, I'm going to use the instantiate function. The instantiate function is a function we use to actually spawn in a game object in our game. So the first parameter that we need to pass in is what object? What do we want to spawn? Of course, we want to use our projectile. The second parameter is at what position do we want to spawn our projectile? we want to use our shot point variable and say dot position. The third parameter is at what rotation do we want to spawn it at, and we'll use shot point dot rotation for that. All right, fantastic. We're all done, guys. So let's save the script, go back to Unity. All right, so I'm going to select my player game object right here, and we need to fill in these variables. So shot point, I'm going to drag and drop my shot point object that we created just before inside of this slot. For the projectile, we went ahead and created a prefab already for it. So if you go to the prefabs folder, you'll see that we've got this player projectile object. So I'll select the player and drag and drop the player projectile object in here. And let's say the time between shots is going to be every 0.3 seconds. So every 300 milliseconds, the player character is going to be able to shoot. Let's press play. And I'm going to click on the left mouse button. Boom, you'll see that a projectile gets spawned. And you'll see that we can spawn in a projectile every 300 milliseconds. Now, of course, at the moment, these projectiles are not moving forward. So that's what we have to do now. So I'm going to go back inside my scripts folder. I'm going to right click and create a brand new C# script called projectile. Okay, so once it has been created, I'm going to select my player projectile prefab. I'm going to come to the bottom of it, and I'm going to add the projectile C# script to it. Let's now double click on that script to open it up inside of Visual Studio. So again, the first thing that we want to do is create a public float variable called speed so that we can control how fast this projectile is going to move. Now inside of the update function, we want to go ahead and actually move the projectile. And we're going to use the transform.translate function. There you go, let's put a pair of parentheses and a semicolon. Now to make the projectile move straight forward in the direction that it's pointing at, we're going to say vector3.up. Now we're going to also multiply that with our speed variable. And of course, whenever we're working with movement, we need to multiply it with time.delta time. There we go. And that's all we need, guys, to make our projectile move straight forwards. Okay, let's save the script and go back to Unity. All right, so I'm going to select my player projectile prefab, and I'm going to give it a speed of, let's say, 25. There you go. Now let's press on the play button. And just like that, guys, you'll see that our projectiles are now moving forward, and it's looking awesome. Let's now tackle step 4 of making this top-down shooter game in Unity, and that is to get our enemies working. So inside of the prefabs folder, guys, we've already set up a little enemy for you. So he's right here. Just go ahead and drag and drop him inside of the hierarchy. Fantastic. So we've got this enemy, and the goal is that we want this enemy to move towards wherever the player is. So to do that, I'm going to create again a new script. So I'm going to go inside the scripts folder, right click and create a C# script that I'll call enemy. Okay, so once that script has been created, I'll select my enemy in the hierarchy here, and I'll drag and drop the enemy script onto him. Let's now double click on the script to open it up inside of Visual Studio. Again, like usual, guys, we're going to start off with a public float variable called speed so that we can control how fast these enemies are going to move. Then inside of the update function, I'm going to set the current position of this enemy, so transform.position, and we want to set it equal to vector2.move towards. There we go, supersetting the current position of this enemy to this vector2.move towards function. This function is going to take in 3 parameters: the current position, the target position, and the speed. So what's the current position of the enemy? That's of course just transform.position. So that's his starting position. What is the target position? So where do we want the enemy to move towards to? We want him to go towards the player. So that's something that we need. We need a reference to the player. To do that, I'm going to come up here and create a transform variable called player. Then inside of the start function, so whenever this enemy is going to get instantiated, it's going to run the start function. Inside of the start function, we're going to set player to be equal to find object of type. Then I'm going to put these little signs right here, and in it, I'm going to write player controller. Then put a pair of parentheses and a semicolon. So what is this line doing? Basically, find object of type player controller is going to search your Unity scene for an object that has the player controller script attached to it. It's going to find that object and it's going to store it inside of our player variable. Now at the moment, this line of code is going to get the game object, but we want the transform component. So I'm just going to add after this dot transform. There we go. All right, now guys, we've got a reference to the transform component of our player. So right here, I'm just going to say player dot position. So we want to go from the current position of the enemy to the player's position. Now the third parameter is the speed at which we want to do that. So I'm going to use my speed variable, of course. Like usual, whenever we're working with speeds, reflex, we have to multiply with time dot delta time. All right, fantastic. That's all we have to do for the script at the moment. So let's save the script, Control S or Command S if you're in the Mac, and let's go back to Unity. Okay, so I'll set the speeds of my enemy to, let's say, 6. And let's press on the play button. And just like that, guys, we've got our enemy that is viciously following the player around. All right, fantastic. All right, let's now tackle step 5 to make this top-down shooter game in Unity, and that's to create a spawner system. So we basically want to spawn in these enemies over time. So let's do that right now. The first thing that I'm going to do is I'm going to select my enemy, I'm going to come to this override dropdown, and I'm going to apply the changes that we made to the enemy prefab. And now we can simply go ahead and delete them from our scene. Now I'm going to right click inside of the hierarchy and I'm going to create a brand new empty game object that I'll call spawner. Okay, I'm also going to reset the transform component just to keep things nice and clean. I'm going to go to my scripts folder and I'll right click and create a brand new C# script called spawner. Okay, so once that script has been created, I'm going to select my spawner game object and I'll drag and drop the spawner C# script onto it. Let's now double click on it to open it up inside of Visual Studio. So again, guys, just like for the shooting, we're going to have to create a timer system. So I'm going to create a public float variable called time between spawns. And then I'm going to create another float variable, this time a private one, called the next spawn time. All right, so those are the variables that we need to create our timer system. Now we're also going to create a public game object variable for our actual enemy prefab. So this is the object that we're going to be wanting to instantiate. Now another thing that we're going to need is some spawn points, some positions at which we're going to spawn in these enemies. So I'm actually going to create a public transform array. So to create an array, I'm just going to write transform and then add a pair of square brackets. I'm going to call this the spawn points. All right, let's save the script and go back to Unity and let's create those spawn points. All right, so underneath my spawner, so I'm going to right click on my spawner and I'm going to create a new empty game object called spawn point. And then I'm simply going to place this spawn point somewhere around my map. So for example, right here. All right, there you go. So I've got my first spawn point right here. Now I'm just going to simply select my spawn point, press Control D or Command D if you're in the Mac to duplicate it. And I'm going to place the other spawn point somewhere around here. Now guys, just repeat this process until you have spawn points all around your map. All right, great. So I've got all my spawn points now. I'm going to select my spawner C# script. I'm going to lock the inspector by clicking on this little icon right here. Now I can select all of my spawn points by shift selecting them. And I'll drag and drop them inside of my spawn points array. Fantastic. I'll now select my spawner again, unlock the inspector. I could set time between spawns to, for example, 2 seconds. So I want the enemy to spawn every 2 seconds. And we have to also drag and drop our enemy game objects prefab here. So I'll go to my prefab folder, select my enemy, and drag and drop him inside of this slot. All right, let's now go back to our script and actually make this whole spawner system work. So I'm going to go inside my update function and start by creating that timer. So if time.time, so if the current time in the game is greater than our next spawn time variable. If that's the case, I'm going to reset next spawn time to be equal to the current time in the game, so time.time plus time between spawns. Now here, guys, we actually want to go ahead and spawn in our enemy. So again, to spawn in an object in Unity, we use the instantiate function. The first parameter that we need to pass in is the object that we want to instantiate, so I'll use my enemy variable that we created right here. Then we need to go ahead and find a position. We want to find a random spawn point to spawn this enemy. So before this line of code, I'm actually going to create a transform variable called random spawn point. There you go. And we want to fetch a random element inside of this array, a random spawn point. To do that, I'm going to say spawn points, pair of square brackets, semicolon. Now here, guys, we basically want to generate a random number between 0 and the length of this spawn points array. To generate a random number, I'll just say random.range, then put a pair of parentheses. And we want to generate a random number between 0, comma, spawn points.length. And that's how we get a random element inside of an array. Now that we have that, I'm just going to say random spawn point dot position. So we want to go ahead and spawn in our enemy at our random points position. And we don't want any particular rotation. So to say no rotation, we use quaternion dot identity. All right, fantastic. And that's all we need to make this simple spawner system work. So let's save the script and go back to Unity. And you'll now see, guys, that we've got a new enemy spawning in every 2 seconds from a random position, from a random spawn point, basically. All right, fantastic. So there you go, guys. 5 steps out of 6 are done. And now we're going to tackle the final step to make this top-down shooter come to life, and that is to create the damage systems. So when an enemy touches the player, we want to basically restart the game because the player has lost. And when a projectile touches an enemy, we want to go ahead and destroy that enemy. All right, so let's start with the projectiles destroying our enemies. So I'm going to go back to Visual Studio and open up my projectile C# script. In here, I'm simply going to create a public integer variable called damage. So this variable is going to dictate how much damage will our projectile inflict to our enemies. Let's save the script, and now I'm going to go inside of my enemy C# script. In here, I'm going to create a public int variable for my health. There we go. So this variable will control how much health does our enemy have. Then I'm going to create the void on trigger enter 2D function, and it's going to take in as a parameter a collider 2D called other. So basically this enter 2D function is a function that gets automatically called by Unity whenever our enemy is going to collide with another object. And the object that he's going to collide with is going to be stored inside of this other variable. So inside of this function, I'm going to check if other.tag equals projectile. So we're just making sure that the object that our enemy collided with was a projectile. If that's the case, then we want to deal 1 damage to our enemy. So I'm actually going to create a function. So I'm going to create a void function called take damage. And I'm going to take in an int parameter called damage amount. All right, so inside of this function, I'm simply going to decrement the health of the enemy by that damage amount parameter. And once we've decremented the health, we're going to check if health is less or equal to 0. In that case, our enemy is dead. And so we'll just want to go ahead and destroy the enemy. To destroy an object in Unity, we use the destroy function. And inside of the parentheses, we need to specify what game object we want to go ahead and destroy. In this case, we want to destroy this game object, the one that has this enemy C# script attached to it. So I'll just say game object. Make sure that this time game object has a small g. All right, so here, so if the object that we collided with was a projectile, I'm going to call my take damage function. Now guys, we need to specify how much damage do we want to deal to our enemy. And of course, that is going to be dictated by this int damage variable that we created on the projectile. So to get access to that, I'm going to say other.getComponent. So we have to get the projectile component on the object that we collided with. So there we go. So I'm saying other.getComponent projectile.damage. Fantastic. And that should work correctly, guys. So let's save the script and go back to Unity. So make sure to select the player projectile and make sure that the projectile tag is attached to our projectile prefab. Then I'm going to come down here and I'm going to set the damage of this projectile to, let's say, 1. Then I'm going to select my enemy and I'm going to give him also 1 health for now. Let's press play. All right, fantastic. I'm going to shoot at my enemy and boom. There we go, it's working, guys. Whenever I shoot at my enemy, you'll see that that enemy is getting destroyed. Perfect. So now, guys, we want to do the second step for this damage, and that is that when an enemy touches or collides with the player, we want to restart our level because we have lost the game. So I'm going to go back to my enemy C# script, and we're going to go back instead of this onTriggerEnter2D function. I'm going to create another if statement, checking this time if other.tag, so if the object that we collided with, has the player tag attached to it this time. All right, guys, so if the enemy collides with an object that has the player tag attached to it, then the player has lost the game. In my game, I just want the player to have 1 single health, and if he collides with an enemy, we want to restart the game. Of course, you could go ahead and create a whole health system for the player as well. But let's do that. So to restart a level inside of Unity, I'm going to come up here, and we have to add a special namespace. So I'm going to say using Unity Engine .scene management. All right, so once we've imported that namespace right here, we come down here and say scene manager dot load scene, then put a pair of parentheses and end the line of code like usual with a semicolon. Then inside of these parentheses, we just need to specify the name of the scene that we want to load. In my case, I called my game scene game, so I'm just going to put game inside of quotation marks, and it's as simple as that, guys. So let's save our scripts and go back to Unity. So yeah, go inside of the scenes folder and make sure that your scene is called exactly game. There you go, it's called game, perfect. We're also going to make sure that the player has the player tag attached to him. He does, and we should be good to go. Right, there you go, so I've got my enemies coming towards me, and if I collide with an enemy, boom, you'll see that my game is restarting. Fantastic. All right, so before ending this tutorial, the last thing that we want to do is to spawn in this little enemy death effect that we created when we destroy an enemy. So if I just go ahead and drag and drop it inside of my scene, you'll see that we've got this cool little effect, just a few little black particles, and we want to go ahead and instantiate this effect when we destroy our enemies. So I'm just going to delete it from my scene for now, and I'm going to go inside of my enemy C# scripts. Now here, I'm going to create a new variable. It's going to be a public game object variable that I'm going to call the death effect. All right, so now that we've got this variable, I'm going to come down here to my take damage function, and right before this line of code where we destroy the actual enemy, I'm going to instantiate my particles. So I'll say instantiate, we want to instantiate our death effect at, of course, our enemy's position, so transform dot position, and we don't really care about the rotation, so I'll say quaternion dot identity just to say no particular rotation. Now guys, really it's important that you make sure that this line of code is placed before this destroy line of code, otherwise it won't run since the enemy will be dead. So let's do that, save the script and go back to Unity. Now I'm going to select my enemy prefab right here. I'm going to come down here, I'm just going to simply drag and drop my enemy death effect inside of the slots. There we go. And now guys, let's press play one final time. So we've got player movements. We could rotate our little weapon to face towards the mouse cursor. And when we touch an enemy, we're going to restart, so we're dead. Of course, we could shoot at these enemies to destroy them. And you'll see that we've got this cool little particle effect showing up, and that just adds lots of juice to this game. All right, fantastic. This game is already looking very good.
Remember that if you want to become a pro game dev who makes money from his creations, sign up to the Game Dev Rocket using the link in the description. Okay, thanks for watching the video. Stay tuned. Cheers.